Well, hello again. Back with another video. I have lots of improvements to show you. Starting with, let's just take a little look around. As you can see, my grounds, which were empty, are now populated with trees. Look how pretty they are. They're all wavy and windy and stuff. If you get close enough, you can even see the individual veins in the leaves. It's ridiculous. Thanks to Quixel scans for the incredible 3D tree models. Yeah, I've got a pathway laid out from the gate to the house. The house has, I can't remember if I showed the roof off in the last video, but yeah. Yeah, then over here we've got a little pond with some benches, a pathway going around, some topography so that it's not all just flat. I'm thinking there's going to be a groundskeeper's cottage over here in the back. I'm not 100% sure yet. And also, what would any, I want to say horror story or horror game. It's not necessarily a horror game, but there's certainly going to be elements of that. What would anything like that be without a hedge maze? I've got one wall of hedge here. I'm still planning that out and how it's going to fit into the game and whether or not I will actually include one. We'll get there. But to start with in this video, I wanted to talk about my cat flap physics. So we've got two doors here. The first one, this one on the left, is the finished model. The plan originally was to use the engine's built-in physics modeling to handle the movement of the cat flap, but that didn't turn out that well. Let me cut in a little supercut of my attempts to do that here. So as you can see, that didn't work out too well. What I ended up with though was, dear, come on engine, don't do that. Yeah, there goes the door again. It appears to have fallen into the landscape. But yeah, what we ended up with, what worked, was this. You can see the cat flap is actually responding. Now, instead of using the physics engine to do that, I had to animate that. That curve looks like this. So I basically had to draw that curve. All this curve is doing is controlling the rotation around one axis. It's all smooth and the wiggle is colored. Now I spent hours and hours twiddling and fiddling with these numbers to get them to look as realistic as possible. That's not to say I won't do some more fiddling with it before it's done. There goes the other door again. The other advantage to not using the physics engine and actually animating the movement of the cat flap myself is, of course, I can then control it later and make it do stuff, possibly creepy stuff, at various points in the game. Anyway, the point of this video, apart from the cat flap physics, is to continue from where we left off talking about the interact system. And to do that, we need to go here to the event graph. Now, we covered the interact message last time. If I just go here and hit play, you'll see, this door is really, it's amazing. I might just leave it here just so that I can watch it fall over every single time I hit play. You'll notice that I've changed the font. There's a bunch of other stuff that I can show you as well, but we'll get to that. Possibly in this video, possibly in a future video. Let's see how long this takes. So what happens after the interact message has been popped up on screen and before the message is hidden again is the character pushes the interact button, which in this case is E, and the button press is here. I'm going to switch on something here so I can show you how it works. This is just a debug. It'll visualize what's happening in game. So, but basically what's happening is we're taking the first person camera, which is this camera here, which is pointed in the direction the player is looking. And we're getting the position of it and the forward vector, in other words, the direction it's facing. And then we're adding a trace length to it by multiplying the forward vector by 100 and then adding it to the position. So in other words, we're just drawing a line straight out from the direction in which the character is facing every time you push E. And it's an invisible line, but because I switched debug on, I've made it visible. So if I go into game now, there goes the door again, and push E, there's the line. And if you can see it there, that red line. And it'll draw that line in the direction you're facing. Now what happens is when the line interacts with something, you'll see it turns green. And you'll notice that it turned green not when it touches the door, but like in the space around the door. And the reason for that is it's interacting with the collision sphere around the door. Well, we spoke about collision spheres in a previous video. This red sphere around the door. So that's what this code here is doing. Once the line trace, let me just switch the debug off so that it doesn't keep drawing those lines. Once the line trace hits something, we do a function called break hit result. And you can see here, this is all of the information you can get out of a line trace. There's a lot, as you can see, but basically all we're interested in at this point is hit actor. So it hit an actor. What actor did it hit? Then we do an is valid check. This is just a safety thing to make sure that the object still exists in the game before we continue. Now you'll notice in between here we have a branch and a check of the can interact variable. And I was doing this, if we go back here, I don't know if you remember, in a previous video we spoke about it. We're setting can interact to positive when your character overlaps an overlappable object, and when the overlap ends, we are changing it back to set off. And the reason for that is that we want the character only to be able to interact with something when they're standing inside a collision box. But I've switched this off because I was having a problem where can interact was getting set to false, and if you entered the collision sphere of another interactable object too fast after leaving another one, this variable was not being set fast enough, and I still don't know why. So you can see I've got B can interact, check causes interact to bug out sometimes, testing play with both results of the branch, remove branch if no side effect. So basically all I'm doing is whether this branch is false or true, I'm continuing the code execution, and I've had it like this way for 3 or 4 days now, and I'm going to leave it for a while, and if there's no other ill effects, I'm going to remove that. I'll probably just leave the can interact functionality inside of the parent blueprint of all of my interactable objects, because even if I'm not using it, because changing something in a parent blueprint can sometimes cause bugs later. Yeah, I'll remove this functionality if there's no other bad side effects. Anyway, after all of this code is done, and we've found out what the line trace hit, we run this function here. Now this is called object interacted with, and it's a blueprint interface. A blueprint interface allows two sets of blueprints to talk to each other. In this case, the parent of all the interactable objects and the player blueprint. If I go into the player blueprint and I look under, I can never remember, is it class settings? Yeah, class settings. You'll see there BPI interact. Now BPI interact is just this function that says object interacted with. So as long as the player blueprint and this, for instance, the back door have BPI interact in it, they can talk to each other through that interface. It's a lot more complicated than that, but trust me, you don't want to go down this rabbit hole. Let's just leave it at that. You'll see here it shows up under inherited interface. This is because this version of BPI interact is actually in the interactive object base blueprint, which is the parent blueprint class of all of my interactable objects. Anyway, so yeah, we call this function, and this then goes back to whatever the object is that we're interacting with. So each interactable object has this event object interacted with in it, and we use the line trace to figure out which one to call. That's what's happening here. Then the first thing we do is we check to see if the door is open. If the door is open, we close it. If the door is closed, we open it. So let's say, is the door open? False, it's closed, so we'll open it. We then get the world location of the door, and we play a sound, which in this case is door open. Now, sounds probably deserve their own video. There's essentially two ways of dealing with sounds. I'm using the simple one at the moment. There's a way more complex one that's new to Unreal Engine that's just been implemented that I haven't even touched yet. So let's wait until I know a bit more about that subject. So we play a sound, we then delay for 0.3 seconds. And the only reason for the delay is we want there to be a small amount of time elapsed between the sound of a door latch opening and then the sound of a door creaking open, which is what the next place sound at location is. Again, we're getting the world location of the door. So, and the reason for that is if, let's just play from here, wait for the door to fall over, thank you. And the reason for that is, if I happen to open the door and then turn sharply in one direction or another, the sound of the door opening would be in stereo. Like so. See there? And let's do it again. Now, I don't know if you can hear that or not, but yeah, trust me, it's in stereo. If we just used the play sound 2D, the sound would have no kind of spatial utilization. That's a very strange way to put that. I'll think of a better phrase and overlay it on screen later because I'm an idiot. Anyway. We then play the open door animation. Now this is a timeline node. I showed you the curves for the cat flap, which are a lot more complex. Basically all that's happening here is we're setting a track here called door open, which is a float. A float, I don't know if I've spoken about floats and a float is essentially a number that has decimal points, so it can be a value between 0 and 1, like there's an infinite number of numbers between 0 and 1, and there's an infinite number of numbers between 0 and infinity. There are two different subgroups of infinity. Yeah, watch a maths video. I can't even wrap my head around this stuff. But anyway, yeah, it's a floating point number, and basically what we're doing is we're taking the result of drawing this curve and we are plugging it into a make rotator on the z-axis, and then we're setting the relative location of the door to that. And you'll see it's plugged into play from start, so that it plays the animation from the beginning every time. And then from the update node, we are setting the relative rotation, which means the door's position is being updated in real time. The next thing we do is we do the cat flap. And yeah, I've spoken about this curve I showed you earlier. It's basically you're getting the wiggle as I imagine a cat flap would respond to the laws of physics. I'll just show you that again. Where are we? I'll just show you that again. So thank you. The door has a smooth curve. While it's opening, the cat flap's inertia is pulling it backwards, and then it's overcompensating. Imagine it being spring loaded. So yeah, that's what's happening there. I don't have to go into too much detail on the maths because you can see what's happening there. Anyway, what we do with the cat flap is we can't play from start every time. I don't know why it bugged out. The only solution I could find to get this to work was to reset the animation when the animation is finished playing. So what we do is we put a tiny delay in here, half a second, and the reason I did that is because when I try to connect the finish pin to the set new time pin, it gave me an error and said you need something in between them. So I delayed it slightly, and yeah, that worked. And then we do the same thing. We make rotator and set the relative rotation of the cat flap, so we're getting that wiggle backwards and forwards. Now we set the variable is door open to positive. We change the interact message to say close door, and then send it to the notify widget. And that's it for open door. And then closed door, as you can imagine, works very much the same in reverse. We play a sound at location, which is this, obviously it's backwards now because the door is closing. So we're playing door creaking. We play the closed door animation, and then we play the sound of a door closing when the animation is finished. We're doing the macro, but remember this is happening when this animation is finished. We're playing the sound. Here's where we're actually doing the animation, and the cat flap close animation is just the cat flap open animation in reverse, essentially. But for the same reasons that I think I've spoken about in previous videos, playing these things in reverse tends to bug out sometimes. So I just tend to make separate animations for forward and reverse. Remembering though that of course this is not an animation like a UI element. It's essentially just a sine curve. But the same principles apply, I assume. And yeah, we set the relative location, set the door to open again, and change the interact message back to open door. And that is how the code for opening and closing doors works. And all of the other interactions that we have in the game work very similarly. For instance, if I go here, here's the actual door in place in my kitchen. I'll just pop our flashlight on and go here to the light switch. And you've got turn light off, turn light on. Now, if I had to open that, just to give you an idea, because we don't have to go through everything, but you'll see that it's remarkably similar. Let's just find kitchen lights. Kitchen lights, here we go. If we open this blueprint, you'll see we have the same show interact and hide interact message, and light on and off. Obviously we're not animating anything. We're doing the same kind of logic to see is the light on, playing the sound of the light switch, and here we're just setting the visibility of the light to on or off. And you'll see we've got red light and point lights 1, 2, 3, and 4. Now if I go to the viewport and zoom out, you'll see it's because the kitchen has 4 lights in it, and then obviously the little red light on the visibility light on the light switch. As you can imagine, this means that every single room in the house has its own custom lighting blueprint, which has to be customized to work and fit into that room. So it's a lot of work getting this stuff set up. Okay, quickly, one more thing before I finish the video off, because I'm very proud of this. The inventory system has been completely revamped. So if I hit the inventory button now, okay, obviously I've changed the font. Not 100% sold on this font yet, but yeah, we'll see. You can now mouse over these things, the inventory items, and if you happen to click on one, you get a closer look at it and a description, and also a back button which takes you back to the main inventory screen, and an exit button which exits out. Now I'm going to expand on this even more, and I'll make a video about the inventory system later, but that is all for today. Thank you for watching. Don't forget to like and subscribe.